Hi, this is Jennifer Telford. I am going to talk you through the ATP production from glucose, from one molecule of glucose and one molecule of fat, which is palmitate, which I'll be talking about in the later slides. So let's get straight into it. We'll talk about glucose first. So as you can see from the slide up here, we're going to start out with glucose up at the very top. The first thing that you're going to go through is something called glycolysis. So the net ATP production from glycolysis is going to be 2 ATP. From glycolysis, you've got 2 pyruvate, 2 acetyl-CoAs, and 2 NADH. Now the NADH requires active transport, which is at a cost of 2 ATP. That next step is going to be going through the electron transport chain. So the total outcome of that is going to be 4 to 6 ATP. Now remember that 4 to 6 is going to be because of the loss of 2 ATP there. So we'll keep that in mind. We got 4 to 6 here. We've got 2 ATP over here. So let's move ourselves straight down. So from the 2 acetyl-CoA that we've gotten from our glycolysis, those 2 acetyl-CoAs are going to go through the Krebs cycle or the citric acid cycle. There's going to be 2 rotations of that, and there's going to be a net production of 2 ATP off the Krebs cycle. So from glycolysis, as well as the citric acid or the Krebs cycle, we've got a net production there of 4 ATP. Now from that Krebs cycle, we are going to have then producing 2 NADHs, 6 NADHs, and 2 FADH2s. And that's going to hit this electron transport chain. Now that Krebs cycle needs oxygen to work. So the production of ATP from the electron transport chain through the Krebs cycle, and this is happening through the mitochondria, is going to be 6 ATP. Then we have 18 ATP and 4 ATP, and that's coming from the FADH2. So when we look at everything and we try to add them all up, we've got the 4 to 6, which is coming from up here. We've got the 6 ATP, which is coming out of the electron transport chain from the 2 NADHs that were over here. The 18 NADHs, that's again coming from those 6. And then the 4, that's coming from the 2 FADH2s, that's going to come from here. So we have a net total from that is either 32 to 34 ATP coming from the electron transport chain as well as the 4 ATP. So the 36 to 38 ATP. Now we have a net loss, remember what I said at the start, of 2 ATP, which is going to require that active transport. So that's where that 2 loss is. And we have a net total of 34 ATP coming from the breakdown of one molecule of glucose. So that's that first one that's a glucose. Now let's move on to the fats. I'm going to move straight into that. So our ATP production coming from one molecule of fat. We're starting out with palmitate, which is a 16 carbon chain here. You then are going to go through 7 rounds of beta oxidation, and that takes place in the mitochondria. So each round of beta oxidation produces 1 NADH, 1 FADH2, and 1 acetyl-CoA. So from the acetyl-CoA, in the very last round of that acetyl-CoA, that actually produces 2 instead of 1. So from that 1 palmitate then gives you 7 NADH, 7 FADH2s, and 8 acetyl-CoAs. So remember from those acetyl-CoAs, we're going to next hit into that citric acid cycle or that Krebs cycle. We've got the rotations from that. Now out of that, 1 acetyl-CoA is going to produce 3 NADHs, 1 FADH2, and 1 ATP. So the total yield from all the rounds, the 7 rounds of beta oxidation that we talked about there, we have 24 NADH, 8 FADH2s, and 8 ATP. That's coming out of that. So moving on to the next slide, we'll keep talking about that. So the beta oxidation, taking those numbers as we did from that last slide, the 7 NADHs plus the 7 FADH2s plus the 24 NADHs plus 7 FADH2s plus we have our 8 ATP that we produced as well from the last beta oxidation or the Krebs cycle. So with that total, we're just adding them up. So we've got from the 7 and 24, we've got 31 NADHs. From the 7 and the 8 FADH2s, we have 15 FADHs, and then we have those 8 ATPs. So we bring that down. The next step, once we've got all this down, we're done with the beta oxidation, we're going to go into oxidative phosphorylation. So during this process, we have one NADH, which then produces 3 ATP. So we take that 31 that we got from up here, those 31 NADHs, multiply that by 3, and we come up with 93 ATP. The next one we're moving into is that 1 FADH, and that produces 2 ATP. So we're going to take that 15 from up here, from that beta oxidation. 15, we're going to multiply that by the 2 ATP to give us 30 ATPs. Then we're going to bring down from the citric acid cycle, we've got 8 ATPs that got brought down. That was from here. Bringing that all the way down, so we have a total of 131 ATP. Now to activate the use of those fatty acids, you actually lose at a loss 2 ATP. So the total net ATP production from one molecule of palmitate is 129 ATP. So 129 ATP versus our very first slide, 34 ATP from one molecule of glucose. So if we're thinking in terms of what that means with regards to exercise, you can see very clearly you've got way more energy that's being produced, and likewise it's stored in your fats. So we've got 129 ATP, which means we have loads of stored energy that comes into our fat. So things like long endurance training, or people who carry more fat have more stored energy, versus something that's being looked at to get quick energy. We're looking at glucose. We've only got 32 to 34 ATP, so it's not quite as much energy. So in terms of exercise, again, if you're looking at something that's low, long distance, like lower in intensity, you're going to have way more energy that you can use there. Where something that's a little bit higher, like a sprint, something like that, you're going to need very short bouts of energy, so the ATP production is not quite as much. So those lower long distance ultra marathon runners, long distance cyclists, hikers, they're going to be working probably more and burning more of their fat in the fat burning zone here, which is what we used to say is a fat burning zone. You've got your extra energy in your stored fats. So that's pretty much as quick as I can make it, within 5 to 10 minutes, in explaining the differences between your glucose ATP production as well as your fat ATP production and what that actually means for our bodies. Thank you very much.